thoughts on a topic that's been bugging me for a while. So, like I said earlier, I'm well beyond my graduate student age and around a few blocks. I've been in the industry, telecommunication industry, internet for quite a number of years. And what worries me is that we seem to be in certain key areas, despite all the talk about rapid progress and all of that, and make very limited progress. And so part of my talk here is to talk about technology, highlight issues, all of that. But part of that is also, on my part, a call to action to you as professionals, as technical professionals. Because I think in many ways, the security issues that the morning sessions have pointed out are, to some extent, if not our personal fault, they are our industry fault. And I think often as individuals, we are too complicit on simply accepting that the best we can do is kind of muddle through and fix that bug or address that little problem or ask users to do something. That clearly has not worked. So I think as technical professionals, we have a responsibility to go beyond doing what we do in the day job and to look at that problem in a bigger scope. If you look at other professions, law and medicine, my sense is that professionals in those disciplines are much more willing to speak up and say, I'm not just going to treat a particular disease with a particular patient, but I'm also going to speak up to change the circumstances that cause the disease and cause the problem. And I think it's time for us to go beyond just simply individual technical pieces. So I will be talking about what I perceive as kind of the dominating fallacies that we have in security, and one I highlighted because it's the most aggravating one, namely the blaming users for doing things. It came up in previous talking and clicking on attachments, or answering PayPal phishing emails, or whatever it happens to be. We need to, I believe, have a much greater emphasis on doing other things, namely reduce the value of targets so that it's less attractive or economically motivated. Avoid this small mistake, huge cost problem that a large amount of the security infrastructure has. So if you look at, for example, the banking, I think it was Morgan Stanley is a good example. 1 out of hundreds of servers had a problem in the sense it didn't require two-factor authorization. That was obviously the server that was found. Much of our security infrastructure has this type of trade-off, which obviously advantages the bad guys. We need to secure key identifiers. We need much harder to scale attacks by essentially putting in things that are intentionally inefficient for the bad guys so that the inconvenience, relatively minor to the good guys, makes the traditional attacks infeasible. We need to design fraud-resistant systems. I'll talk about that one example that I looked at in the commission. And we need to not just worry about denial of service attacks on machines, but also on humans, because many systems, such as the 911 system, are human and machine systems that need to cooperate. Again, key message is, I think we have all technical knowledge, we need to apply it beyond our narrow expertise. Unfortunately, we have a pattern of failure, and again, this may be a US-specific thing, but I don't think it is necessarily. So instead of making it easy and encouraging exercise, we have a thriving pharmaceutical industry that tries to fix after-the-fact diabetes and whatever else. Instead of paying a living wage, we worry about common course testing standards and paying for testing. Instead of building transportation, we design apps that somehow give us the illusion that we can navigate around traffic jams. And in the networking world, instead of finally, after 20 years deploying IPv6, we diddle around with NATs and ICE and stun and turn and all of that complexity that has hundreds of pages of specification just to deal with a problem that really shouldn't exist to begin with. And instead of designing and building and paying for secure apps and operating systems, we have ISACs, kind of these information sharing, which seems to be kind of a congressional response to security. We only share more information about the same bugs that we've been fixing for 20 years. Somehow magically we'll get better at it. We have firewalls, we have lobbies, we have user education, and all of that. So fundamentally, and this is, I think, an indication of the bigger problem, is that we seem to be incapable of tackling the big problem, so we try and kind of maneuver around by mitigating the small problems. I don't think that's going to work. It's like saying by recycling your water bottle, you're going to solve global warming. Also, we often tend to confuse, when we talk about cybersecurity and security in general, three very different mechanisms, or three different threat models. And this is a simplification. You can probably do a much better job of classifying that. My rough notion is that you have essentially three types of actors people talk about interchangeably, although the model and incentives and mechanisms are very different. You have the script kiddies that are after click fraud and DDoS, and these days they're usually criminal games, not individual teenager type models. You have the higher end individual attackers that want to empty your bank account, and obviously you have various three-letter agencies that have goals which I suppose are classified and thus empty. So the problem is that we often say, oh, if you only encrypt everything, you'll solve your security problem. I just came from an IETF meeting where that seemed to be a theme. But for the script kiddie and the one that's attacking you to use to launch denial of service attacks or to engage in click fraud, encrypting your web connection isn't going to do anything. Encrypting your email isn't going to do anything. That's not how they attack you, that's not what they care about. Same for the one that's after your bank account because they install some kind of Trojan on your machine to impersonate you as you interact with your banking system. A firewall isn't going to do anything, whether on your device or on your network, because they're relying on some downloaded attachment or some flash vulnerability or whatever. And similarly, if you look at kind of the National Security Agency level vulnerabilities, worrying about software updates, as part of previous talk, isn't going to help you much because they're going to use zero-day vulnerabilities anyway, and so very sophisticated mechanisms that inject vulnerabilities into the supply chain. So you don't really have, that is good for other reasons, but not going to defeat that particular asset. So depending on what you look at, and these are very different, it's not just that the attacks are different, the likelihood that you're going to be targeted by one of those differs as to who you are. So providing the same security advice indiscriminately across industries and individuals as if it was one security threat doesn't help anybody because it simply makes difficult things required that actually don't help a whole lot. The second general problem that we have is that we seem to have a limited incentive for companies to actually do anything. The scary thing, and it's sad to say that the impact of these vulnerabilities on companies, including the major breaches, is actually extremely limited. So Sony got mentioned a few times along the way. So the Sony breach had just $50 million cost in investigation and remediation, and they get a little higher, but it is some trivial amount, very low percentage range of the annual revenue. It's rounding error. And this is where revenue varies by natural forces every year. So if you take Target, you would need nothing smaller. Why did we have 0.1% of 2014 sales as cost? Again, weather has a larger effect on Target sales than even such a major breach. And the problem, however, is that none of these costs incorporate the cost to society at large. The inconvenience of millions of people having to call their credit card company, get new credit cards, millions of changes that need to be made so that all the repetitive billing gets corrected, all the difficulties when you suddenly, your payment doesn't go through anymore because you still have an old credit card on some newspaper subscription, all of those things, nobody counts if they don't count for some reason, because they can't be accounted for. A classical problem, an economic problem where the incentives and the costs are completely misaligned. And until we fix that problem, just saying that Target or Sony or Tik, whatever, has an incentive to fix security problem because it's going to be really costly to them, the evidence doesn't support that. There's no evidence that really hurts besides just newspaper headlines or whatever, which will be forgotten in a year or two, that it hurts either any of these high-level targets and high-value targets. The concrete costs are borne by you and me. Until we fix that, so that those costs get reflected back onto companies, we won't fix the security problem. This is not a technical problem, it's an economic, legal, and policy problem. And obviously, the costs are borne by credit card companies. Apparently, the Target one was a major drain on small consumer credit unions because they suddenly had to reissue credit cards, which cost a few dollars each, to all of their customers. And apparently, those costs are borne by the banks or the the financial institution. And now, again, they were innocent victims, never got compensated by anybody. That, until we fix that problem, we're not going to solve the security problem. Again, we have a classical tragedy of the commons problem in a different way. Here is the number as to how much do we spend. This is a few years old. According to that, in 2016, we're going to spend $83 billion on commercial spending. This presumably does not include military and government agencies and so on. Well, then we have the Open SSL project, which has a budget of less than $1 million a year. This is after the Huntley vulnerability and after attempts to increase that, working more or less on volunteers. Unless we fix that fundamental asymmetry, we spend all that money on essentially just patching and looking at logs and doing all these things and fund infrastructure in a common way. And yes, that may involve taxes. I know this is might not probably be yanked off the stage in Texas here, but until we have a way of funding the common infrastructure, we can continue to increase that RAM. And I'm sure lots of companies will make money on it, but that's just saying, oh, we've been doing wonderful because we're spending an increasing amount of our GDP on healthcare. That's a sign of a strong economy. It's the same, this is essentially the version of healthcare indicating we have a problem, not that we're having a growing industry as much as that industry likes it. In 2005, Plano had a list of the 6 dumbest ideas in security. So 10 years ago, and I suspect they weren't new 10 years ago, we seem to have made almost no progress in addressing any of those. We still have largely default permit modes. You can install anything on your Windows PC, and it will let you do that happily. It's very difficult for me as a parent to restrict what kids can install on their Mac or PC. It's very difficult for a small business. Large businesses have other opportunities, but for small businesses to prevent their employees from installing random stuff on their PC. We still be enumerating badness. The advice that you read in every newspaper column is install an antivirus system. Not terribly helpful, but I guess it makes you feel all good about something. We still have the penetrative patch model. We've been patching Java and Adobe Flash for as long as we've been around. They don't seem to be getting any better. The two largest sources of CVE announcements last week that I saw were, surprise, surprise, Java and Adobe Flash. We think that hacking is cool. I guess nobody admits to hacking around here, so I guess it's not true. And we have the same old model of let's educate users about what they should do. When I work in the federal agencies, one of my gigs, on every elevator you see the poster saying all the things that you shouldn't do and all that. Not saying it's completely useless, but it has a feeling of essentially wash your hands so you don't get Ebola. So. And that we do something with action, that we install something with whatever. Create an exchange, a security coordination council, or whatever it happens to be. There's 6 other dumb ideas I think are more specific. US credit cards. Again, the notion when Target got blamed, they obviously did stupid things. They should have done, and it's not, they didn't have the right incentives in place and the right mechanisms, all of that. But they were the victim. They're not a financial service company. I mean, they sell underwear. So the problem they had is that we still have, after all these years, credit cards that have valuable information printed on the back or the front of it. We know how to solve that problem. For various reasons, we've decided, or at least the US financial institutions have decided not to solve it. It's also part of the problem for retail because they don't install new swipe machines, all that. That is the real security problem, not that there was some AC vendor that did something stupid. That was an indirect problem, but the real problem, if we had solved the underlying problem of having credit cards that have no valuable content that gets transmitted to cash registers, you could have had the dumbest AC vendor and an open credit card system there that anybody can log into and still wouldn't have made a difference. We have social security number. Somebody must have not paid attention in security class. Public key cryptography does not mean that you publish your key. And so the notion that you have a social security number that has become essentially the key to your financial kingdom, and that you have to protect that like it's some crown jewel that you can only barely and with embarrassment reveal the last 4 digits of that crown jewel. It just seems like a fundamental failure in design. Protecting the social security number more is just simply trying to fix a system that shouldn't have been designed as. Obviously, again, it's not a mistake of the Social Security Administration, it's a mistake of all the other entities that were too cheap to do something real. Paper checks, I'll talk about that more, that they still exist, is number one, which I saw when I deal with Linux systems. One of my gigs is now I'm on a small cloud system, and so I used systemness on the side. And when I install a version in CentOS or Linux or FreeBSD, whatever, it doesn't really matter. What you get with security you get out of the box is it still allows root logins. It has no 2-factor authentication. You have to do a whole lot of other steps to do that. It has no contextual authentication. Yes, you can add all of those, but it takes a tremendous amount of effort, which means it doesn't get done on your typical WordPress site. And we still have applications that for some reason somebody decided it was a really good idea that every application that you download, whether that's through an App Store type model, not on Android, on iOS, better about it, but on your typical desktop platforms, that somehow all of these applications should be allowed to write to any file that the user has access to. As to why a word processing package should have access to any directory except documents is beyond me, but for whatever reason we seem unable to fix that. And ransomware is essentially modeled, if you downloaded an application, as to why by default it can touch your whole file system and turn your files into encrypted gibberish. Again, that's the criminal is responsible, but the operating system enabled that type of criminality simply because it allows randomly downloaded things to modify all your files, which it has no business modifying. Or that we turned web programming into kind of the entry-level job for people either for hobby reasons, students, whatever, who want to set up various functionality, set up low-end web pages and all that. But it's the same true for WordPress and various content management systems in general. Is we let people design languages that are meant for mass consumption by non-computer scientists that have no type checking, where any HTML, including JavaScript, can be passed through any variable, all of that, and somebody thought that was a good idea at some point. It's still not fixed. If you look at PHP or Python, if you want to do type checking, you have to do it manually, which means it never gets done. It doesn't even get done on professional projects. I won't even talk about things like registered roles if you're a PhD programmer, as to how anybody could see that as being a good idea ever is far beyond. We also have a security approach is typically blame the victim. You should choose a better password, run more antivirus system, maybe pay cash, I don't know. Choose another operating system depending on which aficionado you are. Don't click on that link. We all saw versions of that in the previous talk. Sound advice. The problem is not the advice, the problem we have to give it at all. Now, and again, if we look at what, for consumer level things, is that we really, if I look at what's done in public, and again, we are part of that public that should help make it happen, is that really what people don't do a good job of is really distinguishing what's valuable about information for different contexts. Sony has a very different problem than Boeing does, for example, and I suspect the long-term damage for Sony is probably going to be pretty limited beyond somebody having to resign because very embarrassing email exchanges was more made public. But other than that, there's probably not a whole lot of if I didn't modify any data, long-term damage to them. Very different if you have somebody who relies on confidential IP. So what is really valuable? Well, consumers, possibly medical information, but that's really not individually valuable. Again, it really is one about what you can sell, your credit card number, your social security number, your birth date, and other information that's indirectly valuable. It's valuable, the machine is valuable really because you only use it for DOS attacks, very valuable reason, relatively valuable in volume. For email spam, most of email spam is now sent by botnets, or for advertising click fraud, which is actually gets you a non-trivial number of dollars per click. That is probably one of the most profitable ways of using machines. And in there, you don't care about machine power, you just care about it. You need to distribute your clicks so that it doesn't look fraudulent as if you launch it off on one side. Those are the valuable things that people care about for consumer machines. Again, businesses is different. Fortunately, also mostly on your own. We know that credit cards are somewhat limited, and again, when I see, just go back to an earlier talk, is when people get all excited about things like Bitcoin type thing, they have never been at the receiving end of a fraudulent charge. And the whole point is a Bitcoin that have non-reversible transaction. That sounds really bad to me. That is a bug in the system because in real life, reversible systems are good systems because they limit the damage that bad guys can do, including not just bad guys in the middle, but businesses that are dishonest or whatever. And so saying that Bitcoin reduces the transaction cost to zero means that you're fundamentally forgetting that a good feature, not that I think 2 and 3% charges for credit cards are justified, but a good feature of these systems is exactly that it protects the consumers against much larger and more powerful institutions. So saying Bitcoin revolutionizes finance misses the fundamental aspect of finance for consumers particularly. And if you're a drug dealer or other needs, and Bitcoin is a way to you don't worry about reversibility. Reversibility is done in Texas style more than anything else. So checks, again, this is actually, you can probably read it, that is actually a check that for the company that I run, called HoNeST Conference Services. We manage papers for conferences. No, we're not located in Alpharetta, Georgia, but our friendly bank was more than happy to cash that check. There's no security on paper checks. Unless in this particular case, because we had a business account, we didn't even get our money back because we didn't notice this within 24 hours. So the current checking system leaves individual, particularly small businesses, completely unprotected. Let's talk a little bit about authentication. You've all seen that if you take any security course at all, namely the typical something you know you have when you are. I think increasingly what we'll see is an important part is be something where you are. Because again, we know because of smartphones where somebody is legitimately. So if somebody logs into my bank account from Russia, there's a pretty good guess that that's not me. Doesn't matter if I know my password. Doesn't matter if I know my mother's maiden name. It's not me because I haven't been in Russia. We don't really use that information, at least as a default. I think it's starting to happen. It's still far too hard for most websites to use the type of location information that's available in that. This is an easy one. I think the notion that we should make ever more complicated password policies and that's somehow going to help. You read that in newspaper articles about various hints how you can create passphrases, all of that. Again, it makes you feel like you're doing something. In almost all cases, it's completely useless because if you use the same password or some variation, if there's a really sophisticated attacker, they'll figure it out. If not, they'll just use the easy passwords or they just use the password file as is if the website didn't encrypt it. And choosing a more complicated password that's stored in plain text on the server, which is being broken into, doesn't seem to accomplish much. The other one is, I think we're getting beyond that. The notion that it was a bad idea to write down passwords is a classic notion of mistaking what the threat model is. The threat model is not that somebody is going to rummage through your garbage and find your passwords, or that the person fixing your toilet is suddenly going to find a sticky pad on your refrigerator with your password on it. That is a movie plot scenario. That's not a scalable scenario that's interesting for consumers. So we have been giving collectively as a security community, giving advice that basically means choose impossibly to remember passwords. Use a different one for every site, but no, don't write them down. And by the way, the only real security that matters is that of your email account, because everybody has a security recovery mechanism which sends email to your email account. So by the way, the only real security that matters is your email. We don't really tell that to people. Right? Length matters. The most effective means of reducing crime is to reduce the economic payoff. One reason that at least people who know much more about it than I do have claimed is that pickpocketing in general, and if you compare the US to Europe, is much lower. There might be skill level, manual skill level in Europe might still be higher, but the other part is that most people just don't carry that much cash with them. So if you pickpocket somebody, unless you get their credit card and other valuable information, the economic reward is low. So if we can, and I think that's also been true why the number of break-ins, relatively speaking, home break-ins has been decreasing simply because the value that you get by breaking into places is relatively low. If you don't have money, the value of an old PC or an older PC degrades pretty quickly, for example. So what are you going to steal if you don't have a lot of cash or jewelry at home? So reducing, the most effective way of reducing crime is reducing the incentive to do that. And that's usually beyond what we can do, but that's the larger ecosystem can do that. If you don't have anything valuable on your PC, no numbers, no credit card numbers or social security numbers, the incentive of stealing it is far lower. That does far more than all the encryption and all that we can do, which is never going to be perfect. We've tried, I think, we're doing away with passwords. I won't bore you with all the alternatives that people have. The problem for that is they tend to be non-generalizable. A swipe password that you have on your phone doesn't really work on your Mac or PC. They're often not very precise, so often they mean that if you have some impairment of some sort, you have code for voice recognition, say, you have a problem, you always have a password fallback, which means you went back to where you were when you started out with passwords, because the bad guys didn't want to bother with sophisticated biometrics, they're just going to use the fallback password. Here you have the problem that it's hard to have many different ones of these, like you only have one fingerprint typically. It's useful as a value supplement, but I don't see that as the solution that biometrics don't fix things. I do believe what we're kind of probingly converging towards is the oldest model of security, namely having something physical in your hand, a key. A physical key, not a crypto key. And the reason that this is good is two things that are important. Namely, one is you recognize usually pretty quickly when you no longer have the keys in your pocket. That usually only takes you a few hours. You don't notice when your password is gone. You may never know. You generally notice when your physical keys are gone. And it is generally fairly hard, under most circumstances, to scale duplicating physical assets. Do that, but it's hard to do that at scale, and so if the value payoff per breach is low, the economics get far worse for the bad guy. So I do see kind of beyond moving the old version of these number keys where you type in a set of numbers, which seems very kludgy, even it's still quite common, to kind of a YubiKey type of model, to other models that essentially use a physical artifact that is non-programmable, meaning it can't be attacked by modifying the code, that is recognizable, that is cheap, that can be reused across multiple sites, which is a problem with these numeric keys. You would have to have a dozen of them to do that. That to me seems like a reasonably promising approach because it reflects the human nature of recognizing physical things. We are much better at physical things than we are at noticing virtual things. So time security to physical things has, I think, the largest amount of promise that we can get with like this. The other one is that I see an opportunity for high value transactions. Again, if you think about banking, the vast majority of stuff we do is eminently predictable. We pay the gas company, or is just read only. The only thing you worry about is writing checks or sending money to random places elsewhere that you cannot easily get back. For those transactions, for most of us, are extremely rare, particularly anything above a few $10. I mean, paying somebody for dinner or something like that. But most of us don't make random high-value transactions to people we've never met and to entities that are not well known, like the local electric utility, something like that. So for those type of things, having a physical way of easily validating electronic transactions is missing. I saw a version of that in Germany where I set up a bank account. You have to go to the post office, money source for the US post office maybe, and you had to present yourself physically, you had to present a piece of paper saying that you wanted to set up a bank account, you had to present an ID to the person to do that. It was a hassle, but it was very hard to just set up random bank accounts that way at scale. Probably slip one through somewhere, but it's hard to do that at scale. So how do we do on a larger scale now? How do we secure the internet question? And we have a broken internet, with some version of that before. Today here, when we talk about that as if we only got to do the internet again, we would come up with a secure version. I don't think that's actually true, as long as you don't tell me what you're going to change. Because if we look at, for example, the internet layer, having authentication at the internet layer buys you very little. Yes, I know that packet came from Nigeria. Thank you very much. I know that today. I don't need crypto for that. Doesn't help me much. Either I care about packets from Nigeria or I don't. If I have broken-in machines, the packet from Nigeria might actually coming from New Jersey because they broke into a machine in New Jersey, so even that doesn't help me. And all the authentication is going to make any difference. So we need to, securing the internet layer to me is largely missing the point. There's some things you can do, I think we can, I'm not going to belabor that, I think we could do better, but not a whole lot. The transport layer is mostly a software problem, was alluded to, that client certificate validation, particularly for client certificates, is difficult to impossible. Nobody has client certificates for whatever reason. And the application layer is a much better source because it knows what and who. It has much more contextual knowledge. It knows more as to what you normally do versus what you don't do. That's probably where the best payback is. The notion that we have a security layer that everybody else can do nothing is, I think, one of the things, fallacies that we should just get rid of because it's not going to happen and it just simply delays what we really need to do. The notion that we're going to have no more unauthenticated packets. In the world that we live in, where you want to give access to content and applications to people you've never met, because they might become your future customers, just doesn't work. There are things that are useful, and currently we use NATs for that we should be doing in a more general way. So for example, I should be able to set up, without going through a NAT mechanism, that I can set up for certain applications that I don't want to talk to you unless I have talked to you first. That should just be something that I can build in very easily, again, without going the NAT route. And permission-based sending and all that. We also have had a problem that many of the technologies, and some are non-security related here, have failed because they weren't really satisfying some key considerations for successful technologies. I won't belabor all of those. You can disagree and hopefully will, where some of the reason for death of those relative technologies, but we generally, for security, we failed on the manageability. We failed on the configurability. Try to configure SSH or try to configure SSH key pairs on a Linux machine. It's getting it right and doing it in a way that key management is possible is still essentially impossible, even for trained system administrators. They will make mistakes. There's no business model, there's no initial gain, there's 80% type of solutions that exist, round solution, and in many cases they make your system more vulnerable because you don't see what you used to see. What we do need to do, and this is something that I think we have not paid enough attention to, is instead of worrying about securing protocols or applications more generally, is what we do need to do is secure identifiers that are key to many applications. So for example, IP addresses. Avoiding spoofability by doing ingress filtering. We know how to do that. The RFC 3013, ECP48 type of thing, we know how to do that, we just don't do it. So claiming we can do something else because we couldn't deploy that doesn't get us anywhere. We need to secure AS numbers. These are routing numbers that are used in BGP. We have a somewhat complicated, very messy system that doesn't seem to get much traction without PPI. We have domain names with routine failures of not just TLS implementation, but the CA infrastructure, which seems to be getting more brittle by the day. Recent China incidents of Chinese CA spoofing various subdomains of Google. Just a few days ago, email addresses, completely unsecured. We know how to do that, we just haven't been able to scale it. Phone numbers, we just worked on that at the IETF yesterday. There's a working group now, if you're interested, many of you telecom, called STIR, which is finally, after 20 years of voice of IP, looking at how do we secure telephone numbers so that you can prove prove to the recipient that you're actually entitled to use that number. That's the major source, by the way, why you get robocalls and why you get calls from the Internal Revenue Service that claim to be Washington, D.C. Calls, all of that. And we also, and this goes back to my previous remark, we still lack a way of having secure location. If we could have an attestable way of telling where you are to various third parties through your cell ID or whatever it happens to be, a lot of security problems would go away simply because it would limit the number of people who can impersonate you. You would have to be in the same cell site as your cell phone, for example, to do that. But in order to do that, you have to have secure location that's not just secure in terms of determination, but also in terms of conveyance. But that could be a very easy way, non-intrusive way of dealing with that with privacy issues I don't have to address. We need to avoid the single failure equals catastrophic failure problem. Basically, if you make one small mistake as a consumer, namely you upgrade your Adobe Flash one more time. Hey, it's only been 3 days since I did the last upgrade. You've just downloaded, as happened, you downloaded a fake installer for something which looks awfully close to Adobe Flash, but isn't. They had advertising links that linked to some installer page which looked awfully convincing. I had to look at the domain name to see that it doesn't look like Adobe. But I mean, I don't think anybody who's not aware of that possibility would have seen that. And again, if you're trained to giving Adobe installer for root privileges even on the Mac, there's nothing you can do about that. So the notion that we have is that an Adobe Flash application can essentially own your system just because you did what you're supposed to do, namely update out of the application. That model can't continue to exist. That's just professionally complete incompetence. If we had, sometimes I wish there were more lawyers. This is one where the notion that Adobe and Oracle and you name your favorite company can continue to impose that burden on society that they're completely indefensible. We need to have separate systems for high-value transactions. So if you do a bank transfer that gets money out of your account to some unknown place, that should not be possible on your web browser. That should only be possible in a much more limited, high security environment that can't do anything else. You shouldn't be able to click on an ad in one instance and 10 minutes later do a bank transfer. How do we secure end system? The old attack model was a port-based model. You have a bunch of ports, NetBuyers, Microsoft SQL. These days, the most recent one is STP, the Microsoft discovery type of protocol that they have, which just DDoS our Columbia network system. So the old port-based model. The new model still exists, obviously, but the new model that is much more, it's essentially downloaded content is where it is. No longer ports and network connections, it's really downloaded content that matters. And in 2014, you had 83% of all vulnerabilities were applications. Hardware was a very small fraction, operating system a relatively small fraction as well. And if you look at vulnerabilities, again, they're all in internet-facing entities that have direct interaction with the internet. Microsoft Explorer, Google Chrome, Firefox, obviously favorite Flash, and Java are there, and the others that are similar to these in various ways. So we know where the problems are. They're all in the same applications because they take untrusted content. So what can we do? We can harden key libraries. We know there's only a very small number of libraries that actually need to see internet content, that actually parse content. We need to separate parsing and system access, and Google Chrome approach in that. Possibly have separate VMs for each enterprise application on the enterprise side, so you can do much more targeted filtering. And we need much better self-learning security systems that themselves tune them, that they know, even if I didn't configure it right, that they still learn that this is an unusual way of using the same system. The database knows that it only gets database queries from one IP address. If it starts getting queries from another one, probably bad something. what can we do? We can restrict privileges. We need separate trusted hardware for those high-value transactions. This was said earlier, the notion that systems don't update automatically should be disqualifying for a consumer product. Currently, I can't tell when I buy that thermostat or that camera, I have no idea what that thing is going to do. Is it updatable? What happens when that company goes out of business? I bought the toaster from. What happens in that case? Is there a fallback mechanism? Consumers have no idea. So how do you expect a market to work if consumers can't declare their preferences by purchasing secure products? That's a fundamental market failure that can be addressed by more technology, because it means that the good technology is driven out by cheaper, bad technology. Classical market failure problem. The usual problem, again, the updates that software bugs, actually they have the model is they tend to decrease a bit after first release as they get fixed, and then new vulnerabilities deeper down in the system get discovered and it goes up again, but that usually somewhere after the dip is when people cease supporting that particular product. And so we know that this is a problem for home routers. They're particularly vulnerable because they're directly exposed to the internet by definition. And once you can modify your home router, you can modify DNS, which means you can send you hither and yonder, all that. And they're obviously primary sources for all kinds of denial of service and click fraud and so on attacks. So the NTP reflection attack is just the most recent one. The SSDP attack, I mentioned this a minute ago, all is symbols of that type of thing. Unless we do something about network devices that people buy, it isn't going to change. The notion that we've had of app permissions really isn't sufficient. We really need to have a model which goes beyond that, simply because we know this is a real application. So you have a flashlight application, and I extracted some of the very popular one, obviously it's 600,000 ratings, let alone how many downloads. It needs to know your location, your fine-grained GPS location. Now, why does a flashlight need to know where you are? It's not like it can detect if it's dark outside or something. So it needs to have full internet access. That's nice. It needs to know what your phone state is. And it needs to modify your USB storage content and modify and delete card content. Again, this must be pretty sophisticated flashlight. And obviously people don't, and I'm not saying that this thing is doing anything bad, but it is pretty obvious that simply declaring a list of capabilities and having users judge which ones are good and which ones are not clearly hasn't worked out too well. And there's a reason for that, because it's obvious why they need the fine-grained location, because they want to sell ads. Ads get better money if they get targeted, and so they need geographic targeting. The design flaw that ad targeting and general location access were somehow commingled. I'll talk briefly about privacy, that we have a notion that we have a privacy debate, and this deserves a much longer discussion, which I don't have time for, has been, I think, difficulty with debate, and I see a lot of kind of summaries of Washington debates, is that the difficulty we have is that we have an undeclared lack of clarity what we really mean by privacy. There are some people, once you probe and read between the lines, what they mean is privacy is only violated when my bank account is empty. And these days, the only thing that counts is money, so I suppose that's one way. Unless you have a direct financial harm, there was no privacy violation. And others worry about more fear of exploration that you might have, or embarrassment, and so on. But unless we start being much clearer what we mean by privacy, we're not going to have a useful debate about privacy. So, difficulty, we don't really, the emphasis on just data gathering isn't terribly helpful. Location data can be used in very different ways. So unless you prohibit all location data gathering, data fuzzing and all of that doesn't really help you in that case either. So interestingly, to deal with approach a number of years ago, we tried a different approach, namely also using two other considerations, namely how long is the data stored, and who has access to the data once it ends up in the location that you send it to. Does it get sent beyond that? Like that's in the long run, a much better approach. But we haven't seemed to have made much progress in that simply because the debate hasn't totally. So what can we do? So since we've seen toaster pictures here and one more, we have two devices. One is insecure and one is secure. Yes, they're the same device. How do you tell as a consumer? So unless we have a model that allows consumers to have a marketplace idea as to whether they're buying a secure product or a non-secure product, we're not going to get very far. We've had this problem before when toasters, and this is why I picked the toasters, first were developed. Lots of those toasters would go up in smoke and would kill the user in the process. They would toast the user, not just the bread. The way we fixed that is we instituted safety certifiers. Underwriters Laboratory, TÜV in Europe, that basically made sure that unless you got a whey import from China, that you could be reasonably sure that the toaster was reasonably safe even if you stuck a fork in it. We do have some versions of that. Who's familiar with PCI DSS? A few people. The interesting, this is for if you take credit card data, again, that it shouldn't be necessary, I'll leave that aside, but that if you take credit card data, you have to do a bunch of stuff, and among other things that they do is they continuously probe every month or so your website where you accept credit card data, and they'll tell you if any of your software is outdated or if you seem to have an obvious vulnerability. It's not perfect, it doesn't discover all SQL insertion type attacks and so on. But that's a model of a continuous validation system that then enforces, if you want to continue to take credit cards, your necessity to upgrade your systems. It's a nuisance. I'm subject to PCI DSS, so I know what I deal with, but I'm happy it's around because it's a model that works. Strangely, and I'll say that as an aside, the same industries that seem to be perfectly happy on one side of having something like DSS imposed never ever want to have it imposed on themselves. And always say, no, we don't want any external validation. Somehow the banks get to impose it on everybody. In the interest of time, I'll just talk about one additional item because this is something I hadn't known before I got involved in that one issue. Is there are often systems that are particularly vulnerable that combine human and computer systems. Nano One system is a good example of that. Typical 911 call center has a few call takers on duty at any given time. Yes, you can do a DDoS on the network. It's far more effective to do a DDoS on the people, namely by simply making bank calls, as the newspaper article did. Unless we have protections about protecting the people as opposed to simply the network, we're not going to be protecting these vulnerable infrastructures. Let me conclude. Internet security, in my view, is a systems problem in the classical sense. Solving one piece helps, but unless you look at the whole system, you're just kind of patching various pieces, literally in this case. It is not primarily a crypto or protocol problem. Even if we had the ability to change our internet protocols around, it wouldn't fundamentally change the problem. We need to treat security as systems failure, so that means redundancy and time to repair matter, and it matters that we look at this in the same way that other engineering disciplines have looked at it. We know civil engineers don't do the patching model. Oh, the bridge fell down. I guess we should have patched the bridge a little better. I guess that's becoming remodeled in some cases, but that at least didn't used to be the civil engineering ethos. We don't do that for aerospace. We don't do that for medicine. We somehow seem it as acceptable in computer science. I don't think that's good enough for us if we want to be professionals as opposed to just hobbyists. We can't wait for the internet to be secure because it's never going to be secure, and it's by definition, given that it's a random party communication medium. We We need to do change for processes that includes getting rid of credit cards in the current form, getting rid of paper checks, social security numbers, and so on. We need to inform consumer choice so that people know what they're buying. That may mean certification in some cases. And we need to fix the externality problem. And the people that cause the problem need to bear the cost. Until you do that, we're patching around the edges. And that's as much a policy problem, more a policy problem, than a just an engineering problem. Thank you very much.